We are going to talk about web architecture. Web architecture is a process of designing, creating, and implementing an internet-based computer program. Often, these programs are websites that contain useful information for a user, and web development may design these programs for a particular purpose. Web architecture entails every component of an application and helps web developers create designs that enhance a user's experience. Ideally, Ideally, a completed project allows users to access information easily and understand how to navigate its content. While there are many different approaches, strategies, and patterns of web application architecture, the process commonly influences these components. The first component we have is design. This refers to how the program appears aesthetically to a user. Second, we have IT infrastructure. This element of a web architecture program includes coding and software development involved in designing a program. The third one is the user experience. Besides design aspects, web architecture concepts allow developers to implement other program functions that appeal to a user, such as simple language or easy navigation. The next we have is software. Effective web architecture often includes the development of robust software to support the functions of a program or application. The next we have monetization. This refers to the ability to monetize a web program, which developers incorporate into foundational architecture of a program. We again have the efficiency. The methods used to create a program directly relate to its efficiency, both in its design and software level. Then we have reliability. This refers to the web application's trustworthiness and consistency when a user attempts to access it. Emphasizing these components can help developers avoid technical glitches and other issues that may arise on a user's end. We have scalability. While designing, it is important for web developers to consider the potential need to eventually increase the size and reach of the program. The last we have is security. This refers to the level of network security a web program possesses to ensure protection of user data. Alright, so that was about web architecture. Now I want us to move on to look at protocols and standards on the web. In a digital network, protocols are necessary because they provide a set of rules that govern how devices in the network communicate with each other. Without protocols, it will be difficult for devices to exchange information and data in a meaningful way because there will be no standard way for them to encode, transmit, and interpret that data. Protocols are necessary for a number of reasons, including 1. Ensuring interoperability. Protocols ensure that devices from different manufacturers and operating systems can communicate with each other, regardless of their underlying hardware and software differences. 2. Facilitating error detection and correction. Protocols often include mechanisms for detecting and correcting errors that may occur during data transmission, which helps to ensure the integrity of data being transmitted. 3. Ensuring security. Protocols can include measures to protect against unauthorized access and data tampering, which is important in today's digital world where security is a top concern. 4. allowing for efficient communication. Protocols can optimize the way that devices communicate with each other, helping to minimize delays and maximize the speed at which data can be transmitted. Overall, protocols are essential for enabling digital devices to communicate with each other in a reliable, secure, and efficient manner. Now, I want us to continue to look at the difference between standard and protocol. In the context of digital networks, a standard is a document that specifies a set of requirements, specifications, or guidelines that must be followed in order to achieve a certain level of quality or compatibility. Standards are often developed by industry organizations, committees, or other groups, and are intended to be adopted and used by a wide range of individuals or organizations. A protocol, on the other hand, is a set of rules or guidelines that define how devices or systems should communicate with each other. Protocols are used to establish a common language or framework for communication and may include specifications for encoding and decoding messages, transmission and reception of messages, error detection and correction, and other aspects of communication. Standards and protocols are often related to each other in the context of digital network. For example, a standard might specify the physical characteristics of a network, such as the types of cables and connectors that can be used, the maximum distances between devices, and the maximum data rates that can be achieved. A protocol, on the other hand, might define how devices on the network should encode and transmit data, and how they should interpret and respond to data received from other devices. In summary, a standard is a set of guidelines or requirements that define how something should be done, while a protocol is a set of rules that define how devices should communicate with each other. In the context of digital network, standards and protocols work together to ensure that devices can communicate with each other effectively and efficiently. Alright, so move on to look at TCP. TCP stands for Transmission Control Protocol. Communication standard that enables application programs and computing devices to exchange messages over a network. It is designed to send packets across the internet and ensure the successful delivery of data and messages over networks. TCP is one of the basic standards that define the rules of the internet and is included within the standards defined by the Internet Engineering Task Force. It is one of the most commonly used protocols within digital network communications and ensures end-to-end data delivery. TCP organizes data so that it can be transmitted between a server and a client. It guarantees the integrity of data being communicated over a network. Before it transmits data, TCP establishes a connection between a source and its destination, which it ensures remains live until communication begins. It then breaks large amounts of data into smaller packets while ensuring data integrity is in place throughout the process. As a result, High-level protocols that need to transmit data all use TCP protocol. Examples include peer-to-peer sharing methods like file transfer protocol, secure shell, and telnet. It is also used to send and receive email through Internet Message Access Protocol. An alternative to TCP is the User Datagram Protocol (UDP), which is used to establish low latency connections between applications and increase transmission time. TCP can be an expensive network too, as it includes absent or corrupted packets and protects data delivery with controls like acknowledgement, connection startup, and flow control. UDP does not provide error connection or packet sequencing, nor does it signal a destination before it delivers data, which makes it less reliable but less expensive. As such, it is a good option for time-sensitive situations, such as domain name system lookup. After TCP, we then look at IP. IP stands for Internet Protocol. It is the method for sending data from one device to another across the internet. Every device has an IP address that uniquely identifies it and enables it to communicate with and exchange data with other devices connected to the internet. IP is responsible for defining how applications and devices exchange packets of data with each other. It is the principal communications protocol responsible for the format and rules for exchanging data and messages between computers on a single network for several internet-connected networks. It does this through the Internet Protocol Suite, a group of communications protocols that are split into 4 abstraction layers. IP is the main protocol within the internet layer of the TCP or IP. Its main purpose is to deliver data packets between the source application or device and the destination using methods and structures that place tags such as address, information within data and packets. That is that for the TCP and the IP. Now I want to move on to servers. A server is a computer program or a device that provides a service to another computer program and its user, also known as client. In a data center, the physical computer that a server program runs on is also frequently referred to as a server. The machine might be a dedicated server or it might be used for other purposes. In the client or server programming model, a server program awaits and fulfills requests from client programs, which might be running in the same or other computers. A given application in a computer might function as a client with requests for services from other programs and as a server of requests from other programs. The term server can refer to a physical machine, a virtual machine, or to software that is performing server services. The way that a server works varies considerably depending on how the word server is being used. Thank you.